Hey, what's going on, guys? Games here. In this video we're gonna finally connect our transposition table to the Nigamax search, so hopefully it would start working better. I keep referencing the Bruce Moreland's pages on transposition table, and this one in particular. So here with the blue color we have the highlighted lines of how to embed our of how to connect the transposition table functions we've already written in the previous videos within this Bitboard CHESS ENGINE series into our Nigamax search. The only questionable thing that, as I've already been mentioning, I have already been asking this on Talk Chess regarding why to store the hash when we have the depth equal to 0, and actually I didn't yet get a reasonable answer other than not doing question search is a bad thing, which I know myself as well. So anyway, when I've been checking some real-world open source chess engine implementations regarding the transposition table, I've never yet seen like to store the hash entry here. So maybe this is done like for some didactic purposes, I'm not sure exactly. But what actually open source engines do, they do store the beta cutoff, they do store the alpha fail low. So this fail high node, this fail low node score, it's all about the scores. He stores the beta score, the alpha score, and the exact score is stored here in case if this hash alpha flag has been changed within where we have the principal variation node, or literally scores greater than alpha. So without further ado, let's actually embed this stuff into our code to connect transposition table to the search, and then we will try to see how different it's gonna be. So without further ado, let's actually start. So let's start with compiling running the code from the previous part. So I want to make debug, and if it makes run the BBC binary executable, I want to re-enable. Okay, so this is the referencing of hash table or transposition table. We don't need this anymore, and the only thing we need now is this kind of search. So without the transposition table, what we are having here, so we're having this number of nodes being traversed. Okay, good. We have the best move, and we have the principal variation line. So I will probably just I will just grab this sort of the line here for the comparison purposes. So I don't need the time. It's literally enough to make it like this. Save. So actually we need only the nodes, and well, depth is self-explanatory. Okay. So yeah, let's just keep it like this. And now let's go to the Nigamax search function. So assuming that Bruce actually uses this val variable, which I call it the score, right in the very beginning of the alphabet search, that means that this value should be defined here at the very beginning of this search. While where I define this in score is somewhere below currently. So this in score, and also, do I have it somewhere else? Okay, static evaluation, no, not this one, not this one. Oh, and the one in questions. So, well, we don't care about the questions at the moment. Oh, okay, so I also have this score within the null move running. So I'm not really sure that I am allowed to do so. Well, guys, if I'm doing some weird disaster now, please let me know in the commentaries, because this is exactly what I was doing before. So I just want to get rid of this score definition here, and this is about to be replaced. This is about to be replaced right above here as the very first variable to consider. So if I didn't do anything horrible and disastrous at the moment, it should give exactly the search nodes and the principal variation. So where do I start with? So starting with the info itself. Okay, so let's compare to see if it's still kind of the same, if I didn't violate anything, and just to get rid of the time. Okay, it seems to be exactly the same, which is the good news. So we have the depth, okay, score, nodes, and the same principal variation. Perfect. Okay, so now let's go to the Nigamax search and start embedding the code that regards to transposition table. So the first couple of things to consider would be this one. Here we want to define hash flag, and by default the hash flag equals to hash flag alpha. So by default we assume that our node would fail low, so it would be less or equals the alpha. It's not we assume that it doesn't increase the value of alpha. So this is the reason to initialize the hash flag with a hash flag equals to alpha. It would come more clear when we would be changing this flag and then using this flag to record an entry down below here. Okay, so the next thing to consider, so we got the hash flag equals to hash flag alpha. Good. I'm not gonna be returning anything here at the moment, and here I'm assigning to the score. So this is not the value unknown, I call this no hash. This is the constant equal to 100 thousandths. Okay, has been described in the previous video. And also I have the different order for the probe hash. So it's called here not probe hash but read hash entry, and it goes alpha and then beta, and then it goes depth like this. Okay, so again, like, I'm not going to be returning anything at the moment, so just to make sure the code still does compile and run, no hash, excuse me, then how the hell is that called? So no hash, oh, no hash entry. Okay, I call it no hash entry. Okay. Okay. Still compiles and runs, still the same result. Good. And the next thing to consider, so I'm not recording hash here, just because it does give some weird results. Again, like, if somebody can kind of explain me why this is happening, and on the other hand, why on earth did Bruce embed this into his code here, please let me know in the commentaries. I'll deeply appreciate that. Okay, so here we're reading our hash. So here, what we are doing here, we read hash entry, and if the move has already been searched, hence has a value, or this regards to alpha and beta and that as well. We want, we just return the score for this move. We just return the score for this move without searching it. That's it. I will uncomment this later on. Yes, so here we will return the score, not the value. Okay. And the next thing to consider, we need to record our hash in 3 places. So where the beta, when the node fails high, so, well, not in the null move running, but, well, probably it's possible to write data into hash table within the within this null move running. I'm not sure. Maybe I'm talking some weird nonsense at the moment. I'm not sure, but I'm just trying to embed this into the very sensitive and must-have parts of our search. So here, fail hard beta cutoff. So well, let's make it just right before dealing with the with this quiet moves. So we want to store hash entry with the score of, well, let's say equal, no, with the score equal to beta and causing the beta cutoff respectively. So first I have the beta and then the depth, and the flag is hash flag beta. Now I just want to make sure that when I write hash entry, so it goes the score and then the depth. Okay. And when I read alpha, beta, and depth, so score, then depth, then the flag. Okay. Excuse me. Why can't I find this? This is a bit weird. Okay. Oh, because I didn't yet call it like that. Okay, so beta, so score, in our case this is the beta, so beta would get saved within the transposition table, then the depth where this happens, and to give a transposition an idea of what kind of score is this, we say explicitly that this is the hash flag beta, so this is the beta score. Okay, and I want to write hash entry. Okay, and now where the alpha rises right over in here, we want to switch hash flag from storing score for fail low node to the one storing score for principal variation node, and we set our hash flag equals to hash flag exact, because exact flag is the exact flag that is responsible for storing this principal variation node scores. So just want to quickly check this out. So hash flag exact. Okay, and now we also down below here we want to write yeah, I'm just a little bit wondering, can this be made just below this mating scores? Well, in Weiss this is done like that. I'm not pretty sure that much, to be honest, but well, at least this is how I done before. So again, if you guys see something horrible and weird in place in this, so I'll change this to alpha now. So maybe this should be placed here. I'm not sure, but in Weiss at least it's placed right over in here. So that's the reason why I'm doing the same. So this is another questionable question. This is another questionable stuff that might be important. Okay, so here we want to store the hash entry with score equal to alpha. So we're storing the hash entry for the fail low node. Write hash entry and the alpha score and hash flag, not beta, not alpha, but hash flag itself, because this hash flag might be either exact or it might be with the value of hash flag alpha. So depending on whether the search has found a better move than the alpha or not. So if it didn't find a move better, then this hash flag would be would still remain like this is the flag alpha, and in this case the value stored here would be stored as the value of alpha. But if this flag has been changed here, so we found a principal variation node, in this case the same value, this alpha, would be stored, but it won't be an alpha value. This alpha would in this case serve as the exact score. So that's quite pretty important thing regarding transposition table. So let's try to compile and run this, and if it compiles and runs, I will then, oh my god, what have I done? Whoa, I forgot to get rid of okay, some debugging stuff. So let's go to write hash entry, or to read hash entry, or hold on a sec. Well, actually this comes from here. Okay, did I already uncomment that? I don't remember really. I don't really remember. So anyway, we need to get rid of these commentaries. Save, and let's go to Nigamax. Oh my god, what have I done? Not here. Here. Let's go to Nigamax search. Oh, it didn't return anything yet. So yeah, at this moment the score and the nodes, it all should be the same as in the previous time. So the same amount of nodes, the same principal variation line, and now I hold my breath and we'll try to enable my transposition table. So if it finds the proper entry, it would return the score for it without searching a move. Oh my god, oh god, help me please. Okay, so we got the number of nodes reduced from this 56 thousandths to 29 thousandths, which is not that bad at all. And oh my god, oh no, don't tell me, please. Oh no, this is fine. This is just oh, it's not a tricky position. Yeah, why am I so upset? It's not a tricky position. I just remember that the principal variation was starting from B2 takes A6, but that regards the principal variation, that regards the tricky position, not this one. So within the initial position we have this almost a half of nodes being reduced, which is good, and the principal variation line has changed. So now I can't really say if this is good or bad, and that's the most unfortunate thing. So B1 C3. Okay, let's see how it has changed. Just get rid of this time. So now it goes G1 F3 D7 D5. Well, this is interesting, you know, like the principal variation is the same apart from the very first move. And here, guys, I'm not really sure exactly whether this is good or bad, to be honest. We even have the same score. So there is a known issue, like when you have a transposition table, your search starts suffering from instability, which means that for sometimes you might have a slightly different scores. So B1 to C3 is the Queen's Knight move, and this is the King's Knight move. So I'm not really that sure. I actually didn't test it even with this initial position. So if this is horribly wrong, please let me know, because I really need to know if this is right or wrong. I don't know. I need to research this, and after this video I will go for that research, and before I realize how it has to be, I won't be making any other videos. But anyway, what I wanted to show you is actually how this works with the tricky position, because there at least we have the same principal variation line. Okay, so well, anyway, line seems to be pretty nice, I believe. Still, this move changing is a bit strange. And okay, tricky position. So I just want to go to the NinjaMax search, and now I just uncomment this for a while to get the number of nodes and the principal variation line for this position at the depth 7. So here it is, copy, and just paste this in. And now we try to connect our transposition table. Okay, hold on a sec, yeah, the number of nodes is definitely less, but it seems to me that I had a different results here. It really seems to me like that. Well, assuming the force in line, yeah, the principal variation in this case is the same, which is good. We have the number of nodes being reduced, which means the search is working faster, which is also good. But it seems to me that I had even more savings here. So I need to reference my code to make sure that it is actually working as expected. So didn't I miss anything? So alpha, beta, depth. Okay. Right hash entry, beta depth, hash flag beta. Okay. Changing the flag if a better move occurs. Okay. And right hash flag, alpha depth, and the hash flag. Well, it seems to be just kind of fine, but yeah. Well, okay guys, so I will basically drop this video at this particular point because this is the exact place where I am now. Even though I was trying some threefold repetitions and things like that, I didn't yet get done with the transposition table at the level that would satisfy me, so I need to research this a little bit more. But first I really need to go and have some beer. Sorry for that, but I really feel a bit tired now and need to have some rest. So I hope to see you in the next video. And hold on a sec, didn't I? Maybe I just didn't. No, that doesn't matter that much. Okay, so if I find anything like what's going wrong here in the up to the next video, I will definitely share this with you guys. And if some of you experienced guys who knows like what weird disaster did I do in this video, please kindly let me kindly know this in the commentary section, and I would deeply appreciate you for that. Well, okay, so this is it from my side. I don't say that hope you learned something interesting out of this tutorial. I just hope you've enjoyed how I'm suffering from trying to understand how transposition tables works. So if you did enjoy this, that I'm happy. And anyway, I'll see you in the next video. Until that time, and take care.